Alright, today's lesson is changing the values of a and b in the function f of x equals a to the b to the x power, a times b to the x power. Recall that an exponential function can be expressed as f of x equals a times b to the x, where a is the coefficient that's always positive, and b is the base that's also positive but cannot equal 1. All right, let's start with the standard exponential function f of x equals 2 to the x power. And what we're going to do is evaluate each of these values for x. So when x is -3, we're going to get 2 to the -3, which is the same thing as 1 over 2 to the third power, which is 1/8. And if you put that in decimal form, that'd be 0.125. And so on. So if you do this, you're going to get 0.25. And 1/2 is 0.5. To the 0 power, remember according to the definition of exponents, this is 1. So when x is 0, you're going to get 1 for f of x. And of course, 2 to the first power is 2. 2 to the second is 4. 2 to the third is 8. And what you're going to do is you're going to plot these points and graph it. So if you look at this, when x is 0, y is 1. X is 1, y is 2, and so on. And it increases exponentially. But notice down here, it gets very close to the x-axis, but never touches it. This is a 0.125, 0.25. So we don't quite touch that. It goes up and then increasing like that. So this is the f of x equals 2 to the x power. But what we're going to do, we're going to compare when we change the value of a and b and see how the graph changes. So now let's change the value of the base. Let's say instead of 2, we're going to use 1/2. We now have the function f of x equals 1/2 to the x power. So if I plug in -3, I get 1/2 to the -3. And what happens is you're going to flip this over. That's the same thing as saying 2 to the third power. We know that's going to be 8. So this is going to be 4. 2. This is still 1. 0.5. 0.25. So if we were to graph this, notice that the points go opposite from the original graph. So now it's going to look like this. So it actually reflects from the original graph when you make that base 1/2. Let's change the value of a to 1/2. Now we have the function f of x equals 1/2 times 2 to the x power. Last time we changed the base. Now we're going to change the coefficient to 1/2. And we're going to leave the base as 2. So evaluate x is -3. You're going to have 1/2 times 2 to the -3rd power, which is 1/2 times 1. So it's 1/2 times 1/8. When you do that, so you're going to get this decimal here, 0.0625. And if you continue, you're going to get 0.125. 0.25. This is going to be a half though, 0.5. X is 1, f of x is 1. And you get 2 and 4. and you want to plot these points. So when you do that, notice that it's going to stretch out a little bit. It goes in the same direction, but it's going to stretch out a little bit. It won't be as steep. All right, let's change a to 2 and b to 1/2. Now we're going to get this function f of x equals 2 times 1/2 to the x power. And we're going to do the same thing. So you plug in -3, right? You can get 2 times 2 to the 3rd, which is really the same thing as 2 times 8. So that's going to be 16. You're going to do the same thing for the rest of them. This is going to be 8, 4, 2, 1, 0.5, 0.25. All right, you plot these points, it's going to look like this. And it's going to go up in the opposite direction. It reflects, but it's a little higher than the other one. It has the y-intercept's a little higher on this one. All right, this concludes our lesson for today.